A phrase that keeps coming up when people are talking about climate change is that it's an Apollo mission. We're going to invent new technologies just like we did when we first went to the moon. And if you look at some of these quotations, you can see just how many influential and well-known people are reinforcing this message that all we've got to do is try, we can invent a new solution, and all will be well. But I'm afraid it's not true. The difference is that with the Apollo mission, we were trying to get one rocket to the moon, two people to the moon once. That was the goal. But when we're dealing with climate change, we're not trying to do something once. We're trying to transform the way that we all live. If you made, for example, one electric car, that would make no difference. What matters is that we replace all petrol and diesel cars with electric cars over the entire world. It's not an Apollo mission. It's also not about smartphones. A new technology can be introduced very fast. If it's a new smartphone and all the sales channels are set up, all the public regulation exists, everybody knows what it is, it's easy to introduce a new model. But the forms of new energy infrastructure technologies that we'd love to be able to deal with climate change, whether they're new energy sources or negative emissions technologies that literally suck CO2 out of the atmosphere, are not like a smartphone. They're big, and delivering them is a big project. Here's a great example. This is the second Forth road bridge in Edinburgh. In 2004, the Scottish Government discovered that the previous bridge had lost 10% of its strength in the cables due to corrosion, so it had to be replaced, and they did it as fast as they possibly could. And it took 14 years. I've symbolised that with this Z-shaped curve here. In order to get the bridge to the point it was in use at the top, then firstly we have a long planning period, and then we have a period of construction, or let's call it deployment. The planning period has to take a long time in a democracy. During that period, there has to be political agreement about building a bridge, a decision about where it's going to be. The people who are going to do it have to secure rights to the land and all access to the new bridge. We need to discuss the proposal with local communities to understand the impact on them and deal with it as well as we can. We need to understand how much public finance is required and work out how that fits in with other budgets. We need to agree on the design, and we need to do environmental and other legal assessments on the way the bridge is going to be constructed and used. All of that happens before the first spade hits the ground. In this case, it took 8 years. Then building the bridge was planned to take 4, but like many large civil engineering projects, it took a bit longer. It took 6 years. But a suspension bridge is a 200-year-old technology. It's familiar, and there have been many, many suspension bridges built all around the world. This one was a direct replacement. If you're introducing a new technology, a new large energy infrastructure technology, then there's another stage ahead of that planning period, which is dealing with the unfamiliarity of a new technology. Let's imagine we've invented a new way to capture carbon and we're going to store it safely in some way. Well, we would have to develop pilot studies at increasing scale until it was operating at a scale appropriate for being deployed commercially. We'd need to understand the investment case and indeed secure a lot of funding early on before any revenue is generated. We'd need to work out how the new technology connected to the existing infrastructure. We'd need to find out what the public thought about it and how they respond when the first accident occurs. If you think back, then every new energy infrastructure technology that's been introduced has had an accident. And just recently, we know that the disaster at Fukushima in Japan caused the German public to turn away completely from nuclear power. And now you can't have nuclear power in Germany because public fear of accidents was so great. The deployment is also more complicated for a new technology because there's political risk. New technologies, new energy infrastructure technologies require investment, and there is some danger they might not work. So politicians have to commit themselves to the exposure of what happened if it goes wrong. And of course, it's replacing something which is there, and the operators of the existing technology will oppose it. They'll try and prevent the new energy infrastructure technology arriving. That means that it takes a long time to deploy new energy infrastructure technologies. In our research group, we've looked at this in the past, and we've looked at the countries which introduced the new energy infrastructure technologies as fast as possible. And here are the world records for combined cycle gas turbines, nuclear power, and wind. And you can see that in each case, the planning period was 30 to 100 years, and then the deployment rate was never faster than 2% of that country's electricity supply per year. It takes a long time to replace an existing system with a new one. As a result, when we're thinking about what we want to do with mitigating climate change, we need to make a very clear distinction between two types of energy infrastructure technology. One are those which already operate at large scale, and that includes onshore and offshore wind, solar power, and nuclear power. And those are the ones that we can plan to deploy. We already know we've got the systems in place. They're still large construction projects, but we have the systems ready. We know how to do it. For all other new energy infrastructure technologies, we want to try them out. We want to try and imagine everything that might occur, whether it's nuclear fusion, geothermal power, new approaches to taking emissions out of the atmosphere and storing them safely. But they're all in a category where we want to gain experience. They're not ready to be deployed until they've reached some level of serious scale, something like 5% of the market they're eventually going to penetrate. Up till then, they're still in the development stage. It's not just proving that the technology works. We've got to find out if the public will accept it. If you think about fracking in the UK, the public has rejected fracking because they're afraid of it. That matters when you're introducing a new technology. So we need to try everything we can. Innovation is great. It could help us in the future. But in the time we have left to deal with climate change, we must focus on technologies that already operate at scale. We have to wake up to the reality of deployment rates. We have to address climate change with technologies that are available now. By all means, we definitely want to gain experience of every other idea, but we're making a mistake if we confuse gaining experience with deploying something in the short term. So here's a dose of reality. And that means that net zero means absolute zero.